All right, so my name is Lydia Norman. I'm an agricultural education student here at ABAC, and I'm presenting on investigating the better grow black eye as a potential cover crop. So some background on my experiment: legumes are a popular choice for cover crops due to their nitrogen fixing abilities. Common legumes chosen are clover, vetch, Austrian winter peas, cowpeas, green beans, and soybeans. Cowpeas are not the most commonly grown legume for cover crops, but they do well on biomass and shading out weeds when they are grown. In Georgia specifically, cowpea production has greatly decreased due to the cowpea curculio, which is a little weevil that lays its eggs in the pea pod and its larvae eat its way out, which effectively destroys the peas and the pod. The better grow black eye cowpeas are suspected to be resistant to the cowpea curculio, but growers in Georgia need another reason to actually choose to grow this variety other than just it's resistant to the weevil. My question was, when compared to Chinese red cowpeas, which are commonly grown as a cover crop already, Blue Lake green beans, California black eye cowpeas, which are the most common commercial variety of cowpea, and Austrian winter peas, would the better grow black eye accumulate enough biomass to merit being considered as a cover crop? So I had a single season experiment at the teaching greenhouse at J.G. Woodruff Farm here at Abraham Baldwin Agricultural College in Tifton, Georgia. I grew 5 varieties of legumes: California black eye number 5, Chinese red cowpea, Blue Lake 274 green bean, the better grow black eye, and Austrian winter pea. I planted 5 seeds per pot, arranged in a completely randomized design with starter fertilizer and rhizobia bacteria applied at planting. I measured the shoot length and leaflet number of each plant 3 times per week, and 1 plant per pot was chosen on April 4th to be terminated for final biomass measurements. So I took the fresh weight and the dry weight of each terminated plant. Over the course of my investigation, the better grow black eye actually outperformed on shoot length the Blue Lake green bean, California black eye, and Chinese red. The exception to this was the Austrian winter pea. On number of leaflets, the better grow black eye, California black eye, Chinese red, and Blue Lake green bean all performed about the same, with again the exception being the Austrian winter pea. On final biomass, which is very important as a cover crop, as cover crops are used as green mulch, the California black eye, better grow black eye, and Chinese red all performed about the same in final biomass. However, the Austrian winter peas had the lowest final biomass. These numbers for this chart came from this table. Part of why the Austrian winter pea had such a low final biomass after it had the largest shoot length and the largest number of leaflets is actually the habit of the plant itself. So this is comparing the better grow black eye, the Austrian winter pea, and the Blue Lake green beans. So Blue Lake green beans, California black eye, Chinese red, and better grow black eye are all bushier plants. The Austrian winter pea is more of a thin vine with small leaves. I thought it was interesting to directly compare the better grow black eye, which is the resistant variety, to the Chinese red, which is a already commonly grown cover crop variety. So over the course of my experiment, this shows how much the better grow black eye was outperforming the Chinese red. Results of my investigation show that the better grow black eye is worth considering as a cover crop because at termination there was no significant difference between the better grow black eye, which is the resistant variety, and the Chinese red, which is already grown as a cover crop.